Hi everyone, in this video you will learn about 5 different ways to implement a singleton design pattern, so make sure you watch this video till the end. Hi everyone, in this video we will learn about singleton design pattern. So before directly jumping into singleton design pattern, let's first understand what's the creational design pattern. So creational design patterns means a design pattern in which we have to have a rule on how the objects are being created. So every creational design pattern has a different rules of how the object should be created and what are the rules or validations we have to follow for that design pattern. For singleton design pattern, the only rule is that for a given class, you can just have the one object of that. If you are going to create the new object for that, it should restrict that. So this is the singleton design pattern. It's very easy and one of the easiest design pattern, but it has a great usages. So before jumping into the implementation, let's first understand where all it is being used, because it's more important to understand when to use it. So the first example here is like when you are making calls to a remote service. Let's say you have a service which accepts HTTP connection. So let's say there is some implementation of HTTP client. So you just require a single object of that HTTP client which knows how to establish connections, how to send the request, and you just pass everything in the request object. So you just need the one single object of that client instead of having the multiple objects, because if even if you have a multiple objects, they won't serve a different purpose. The purpose would be still the same. Whatever we can do with the one object one, it can be done with the object two as well if we just create a clone as well. But there are downsides of creating multiple objects even if they are doing the same thing. First is that whenever you're creating multiple clients, you might be establishing connection with your service, so there might be a restriction of maximum connections you can establish with a service, so that can time out. Also these type of objects are heavy to create, so it can take time as well, initialization, which can slow down your service. So the other example is database connection. So let's say you have to establish a connection with your database. Now instead of creating the clients again and again which interacts with database, you create just a single client which knows how to perform the different operations. And whenever you need to perform an operations, you just run a, let's say, save query, or like dot get something on top of that. So a single object is required in this case as well. Next is an example of logger. So logging is required throughout your service. So if you have created multiple objects of logging, it will create a overhead of like logging objects knows where to write, like let's say a logging file, and how to write. All those configurations are also present in the logging object. So if you create multiple objects, you won't get any benefit. So having a single object where you have the application level configurations, and you can just use that to write anything whenever you want in your application. Another thing is that for a singleton object, the object is accessible throughout the application. So you would like to create it in the global scope. So before jumping into the all implementations, let's look at the difference between public and private constructors so that we can understand how we can create the singleton object only. So public constructor means like whenever you want to create object, you can create it with the new keyword. So the downside of this is that you can't restrict if you have object creation with the new keyword. So I can create new car, it will create the first object. I create the new car 2, it will create my second object. So we can't restrict how we can just have the single object instead of multiple. So public constructor is not helpful. So private constructor is what is required. It behaves similar to how the constructor works, but the only difference is that outside of the class, nobody can create the objects directly. It means we can maintain some kind of state with the constructor, that from outside we just invoke a method, but inside it knows if the object has been created or not, how many times it has been created, so that we can just create the ones. Now the most important part, how to implement them. There are 5 different implementations and all of them have the different pros and cons. Let's look at that. First, look at the UML diagram. So in this, minus means private, plus means it's a public. So only API which we are exposing is get instance. So outside, to get a singleton object, we will just call get instance, and it knows how to create an object and manage that. So this is a constructor, this is a private constructor, what we discussed in the previous section. Let me change it. And this is a data member which will hold the value of singleton object. So basically the first implementation which we are going to see next is similar to the memoization in DP. So if you have done the memoization part, so what we used to do is that it's in a DP table. If this value is equals to 0, then we will fill this value, else we return that value. It's similar to kind of that concept as well. So whenever we call the get instance, so this is where we will store the instance, and this is our private constructor invocation, and this is our private constructor. So the first is very basic implementation. We will be storing the singleton object here, and whenever someone is invoking it, we will check if the object is not created, we will initialize it. If the object is already initialized, we will just return that variable. So we are maintaining just one state and storing that singleton object there. So basically the first time this code pointer is invoked, and for the second invocation this one is invoked. So there are downsides of this invocation. So let's say there are two different threads running, and both of them reach this statement at the same time. So both of them will create the object. So the object will be created two times, not a single time. That will be overridden, but yeah, there is a overhead, and this is a disadvantage of this implementation. Let's see in future implementations how we can avoid this. So we can avoid the problem which we discussed in the previous implementation using synchronized approach. So synchronized is a way in which for a given code block only a single thread can execute that part. So it holds a lock that only a single thread can run this part, and other threads won't be able to access this part. So how we implement it is like this code part is same, path is same. So this assures that only one thread is able to create the instance and other threads are not able to create the instance. So this is how we prevent uh, creating the multiple instances in a race conditions. But there is one downside of this. So if you see, let's say if you are calling this method 10 times, you require this in your application 10 times. So the first time it holds a lock, it's fine, it created the object. Second time it holds the lock, but it's not creating the object. Third times it again holds a lock, but from second times onward, it just have to return that static data member, but it is holding the lock even when returning that instance, not while the creating as well. So creating the lock is an expensive operation, so you don't want to do it if you don't require it. So we have to somehow overcome that. We should have the lock only in the first time, and when the object is already created, you shouldn't have that lock. So this is overcome in the next implementation. So this next implementation is the advanced version of the previous implementation. The previous implementation has this code block, and this implementation has one extra null check. So what happens is that the first time you are invoking this get instance method, it will come inside and it will lock this. Second time onwards, it won't lock it. So the problem which we discussed in previous section, that solves it. Now the question is why we have this second null check again. So the thing is, let's say till this point, both, let's say there are three threads, thread 1, thread 2, and thread 3. Both reach this stage, but they see a lock. So let's say T1 start executing that. T2 and T3 will still execute it, but T1 has already locked it. So T1 will create an object. Now when the lock is released, if there is not null check here, T2 will also create an object, T3 will also create an object. We don't want it. So this is a double null check. This is to prevent locking when the object is already created. This is for when there are multiple objects which have reached this stage. So for that particular scenarios, we have the second null check. Next one is this, the basic implementation. So the previous were lazy implementations in the way that when you call the get instance for the first time, the objects are created, and if you don't call that instance in your application, no object is created. So this eager implementation is like, you don't wait for the get instance to get called, you just create the object upfront. So the benefit of this is like, there are some of the objects which you know that will surely be required. So let's say logging object, you know that your application, let's say, requires at least one log, so you can create it upfront. So what happens is that it doesn't delay your first operation. So let's say if you don't create the eager implementation of a logging logger object, so you have the logger.error. So the first time you get its instance, the logger object will be created. So in the runtime, sometimes your first call or the first invocation can be slow. So to avoid that, for the instance which you know are used at least once in your service, it's sometimes good to have the eager implementation of that as well. It also doesn't have any lock related any issues, because this is created whenever your application is loaded by JVM. Uh, Next is build pug implementation. So these implementations rely on the locking as well, but it doesn't implement locking by default. It's using the JVM locking thing. So basically, it has a public class and there is a private helper class. So this private helper class will return you the instance. So basically, so this will return it, this will create it. So whenever you call the get instance, at that time, so whenever this class is loaded by the JVM, only this class is being initialized. There is no reference to this class, so this class was not initialized. So whenever you call the get instance, it sees that there is something you need to return from the helper class, so it goes ahead and implements this class. So now whenever this class is being loaded, so JVM holds a log that this class is being initialized or loaded once only, so by a single thread. So that holds a log, and in that log you create the singleton object once and then return it. So the next time you just return instance, it knows its value and it returns as it is. So this is the next fifth implementation. So this singleton object is used in many applications, and it's one of the core thing to create the objects which are required to just create ones. So Spring, which is a Java based framework, it has implementations using @beans. So @beans creates the objects, and Spring manages its life cycle. It creates by default all in the singleton scope. Similarly, there are other dependency injections which Google use and Dagger. They provide @singleton method to annotate your classes for which you want to create just objects for a single time. So this was all about this video about the different implementations where all it is used. So that's all from this video. Thank you.